degree of reaction, performance characteristic, draft tube, types and analysis, causes and remedies for cavitation phenomenon, governing of turbine, similitude and dimensional analysis of hydraulic turbine. So, this is actual photograph of Francis turbine that we have used in power plant. So, this is reaction turbine in this. This is curve shape blade here, and this is casing. Okay. Now see here reaction turbine. This is in reaction turbine, water at the inlet of the turbine produces kinetic energy as well as pressure energy. As the water flow through runner, a part of pressure energy goes on changing into kinetic energy. A water flow through runner. So see here, the water through runner is under pressure and the runner is completely enclosed in airtight casing. So casing and the runner is always full of water. So different types of reaction turbine are radial flow turbine. This classification. Here, radial flow turbine in these two types, inward and outward. Inward radial flow reaction turbine and outward radial flow reaction turbine. So water flow from outward to inward. Water flow from outward to inward, that is called inward radial flow reaction turbine. And water coming from inward to outward, that is called outward radial flow reaction turbine. Simple. Inward radial flow means water coming from outlet to the shaft of the turbine. That is called inward. Outward means water going from shaft to the outside. That is called outward flow. Have you got it? So mixed flow of Francis turbine, water enters radially but remove axially. That is called mixed flow turbine. Water enters radially and remove axially, means according to direction of axis. Axial flow turbines, water enters and remove axially. Here, Kaplan turbine and propeller turbine, this is axial flow turbine, and Francis turbine is a mixed flow or radial flow turbine. So, see a main component of radial flow reaction turbine. Here, we can discuss here. There are many components used in radial flow reaction turbine, but the main component of radial flow reaction turbine are casing, see, this is casing, this is casing, 1 minute. Spot, guys, eraser. accurate. Here, this is your casing. Second, guide mechanism. This is adjustable guide vanes. The runner, this is your runner. Draft tube, here at the center, draft tube is present. Okay. Now, this is see, this is guide vanes. This is runner here, draft tube. This is side view, actual. Score casing, this is main shaft. This is out race. This is draft tube. This is guide vanes here, runner. See, here, actual photograph of Francis turbine. You can see here. So we have discussed here one by one all component of Francis turbine. Here reaction turbine. In case of reaction turbine, casing and runner always full of water. But in case of Pelton turbine, it is work on atmospheric pressure, so not required to always full casing by water. The cross-section area of this casing decrease uniformly along the circumference to keep the fluid velocity constant in magnitude along its path toward the guide vane. See, the cross-section area of the casing decrease uniformly along with circumference to keep the fluid velocity constant in magnitude along its path toward the guide vane. So, this is so because the rate of flow along the fluid path in the volute decrease due to continuously entry of the runner through opening of the guide vanes. See, this is so because of the rate flow along the fluid path in the volute decrease due to continuous entry of the fluid to the runner through the opening of the guide vanes. The guide mechanism or guide blade, it is a stationary circular wheel. Guide vanes are fixed on guide mechanism between two rings in front of wheel. The guide vanes allow the water to strike the vane fixed on the runner without shock at inlet. The quantity of water passing through the guide blade depend on the position of the guide vanes. So, see here at the outlet of the runner, guide vanes are present. It is stationary circular wheel. Guide vanes are fixed on guide mechanism between two rings in front of wheel. The guide vanes allow the water to strike the vane fixed on the runner without shock at the inlet. The quantity of water passing through the guide blade depends on the position of the guide vanes. Means here we can adjust blade angle here. Okay. So runner, it is a circular wheel on which a series of radial curve vanes are fixed. Surface of vane are made very smooth. The radial curve vanes are so shaped that water enters and remove the or leaves the runner without shock. Materials used for the runner: cast steel, cast iron, stainless steel. Runner is geared to the shaft. After that, after that, the pressure at the exit of the runner of reaction turbine is generally less than atmospheric pressure. Hence, water at exit cannot be directly discharged to the tail gas. A tube or pipe or gradually increasing area used for discharging water from the exit of the turbine to the tail gas. This tube of increasing area is called draft tube. For increasing pressure, we have used draft tube at outlet of the turbine. Here, inlet and outlet water turbine. Hello. Hello. Now is okay. See here,
Hello.
after that,
Yes, sir. Now is okay.
inward and outward radial flow reaction turbine. Here, what is difference? Water enters at the outer periphery, flow inward and toward the center of the turbine and discharge at the inner periphery. Outward radial flow reaction turbine, water enters at the inner periphery, flow outward and discharge at the outer periphery. Means inward, water coming from outside to the shaft, toward the shaft. That is called inward. Outwards means water coming from shaft to the outside. That is called outward radial flow reaction turbine. The outer diameter of the runner is inlet and the inner diameter of the runner is inlet. This is major difference. So see here, the inner diameter is outlet D1 greater than D2 and hence U1 is greater than U2. And the outer diameter is outlet D1 less than D2 and U1 less than U2. So, see here, Francis turbine runner shown in this figure, that also inward flow turbine diagram, runner diagram. See here, this is shaft. On the shaft, this runner are mounted or keyed. After that, this is your moving vanes or adjustable vanes. Here, water coming from like that outside to inside. So, this is called inward flow turbine, means water coming from outside, means this side, like that. So, see here, inward and outward radial flow reaction turbine. Inward flow, water coming from outside, but outward flow, water going from inside to outside, like that. This is outward flow. So, this is velocity triangle for inward radial flow turbine and outward radial flow turbine. You can see here. So, this is different at R1 and R2. Here, R1 is outer radius, but here R1 is inner radius. This is major difference. For use this concept for solving the problem, because in problem we have given inward flow reaction turbine or outward flow reaction turbine. This diagram for inward flow, this is for outward flow. Outward flow velocity diagram. Say work done and hydraulic efficiency. See here, work done and hydraulic efficiency are same for both inward and outward flow reaction turbine. Work done per second equal to rho A V1 VW1 U1 plus or minus VW2 U2. See here, work done per unit weight find out by 1 by G into the VW1 U1 plus or minus VW2 U2. So, using these two formulas, we have calculated work done per second for the Francis turbine, inward and outward flow reaction turbine. After that, finding hydraulic efficiency, it is the ratio of runner power to water power. So, how to find out runner power? We have found out here, this is your runner power. Water power finding by formula rho GQH, this formula. So, hydraulic efficiency equal to, after cancelling rho Q, we are getting Final equation VW1 U1 plus or minus VW2 U2 upon GH. This is your hydraulic efficiency. Now Francis turbine, mixed flow turbine. Water enters radially and removes axially to the direction of shaft. Reaction turbine, at the inlet of turbine, both kinetic as well as pressure energy is available. It is generally operated under a medium head and flow rate. So it is designed by American engineer J.B. Francis in 1849. So see a component of Francis turbine penstock for water carrying from dam to turbine. Governing mechanism for controlling the speed of the turbine, spiral casing for keeping the constant energy, runner for producing power, guide blades for guiding the water or change the direction of water, draft tube to increase the pressure of the turbine. Now see here, this is picture of a view of Francis turbine. Here very clear, you can see here, this is casing like that. This is your runner, this is runner, this is draft tube. This is your runner, this is shaft, this is your van, guide vans, see here, guide vans. So water, in case of water coming from this side like that, firstly change the direction or angle, change the angle by this guide vans. After that, water going towards the runner. See these guide vans, we can change angle by manually or automatically. Any doubt, any queries in this diagram, please ask me. This is a view of Francis turbine. Any doubt, any queries? Okay. So see here, this is photograph of Francis turbine. See, this is guide vents. We can see in previous diagram or picture, runner vents, terrace, draft tube, all things we have seen in this picture. See, this is runner vents, this is guide vents, this is draft tube, this is shaft, okay, this is casing. So, see, penstock is large diameter. Before going discussing all these components of this transistor turbine, see here, this is guide vents, means here area increase, means this work as a nozzle, means your pressure energy convert into kinetic energy here, like that. Water coming from this space means working as a nozzle. This is core casing. Means here pressure energy convert into kinetic energy. Also here. Means increase the speed of the runner. See here, penstock is a large diameter conduit which carries water from dam or reservoir to the turbine house. Since Francis turbine required large volume of water, the pattern wheel size of penstock is bigger in case of Francis turbine. This spiral casing. So water from the penstock enter into the spiral casing which completely surrounded the runner. This casing is also known as floor casing or hollow. The cross-section area of this casing decreases uniformly along the circumference to keep the fluid velocity constant. Its magnitude along its path toward the guide vent. This is so because the rate of flow along the fluid path in the volute decreases due to continuous entry of the fluid to the runner through opening of guide vents. Now, guide blade, a series of aerofoil-shaped vents called the guide vents or wicket gates are mounted on the casing. Guide vents are fixed between the two rings in front wheel. However, they can swing about their own axis. The basic purpose of guide vents is to convert a part of pressure energy to its energy at its entrance into kinetic energy and to direct the water of fluid on the runner blade at angle of appropriate to the design. Now, runner, it is the most important component of the Francis turbine. Runner of the Francis turbine consists of series of curved vents evenly arranged around the circumference in the annular space between two plates. The runner vents are so shaped that water enters the runner radially at the outlet periphery and remove its axially at its inner periphery. most of the portion of pressure energy is converted into kinetic energy as water flow through the runner. The driving force of the runner is both due to impulse and reaction and pressure. Okay. Change in kinetic and pressure energy effects. See here, the number of runner blades are usually varies between 16 to 24. The runner is created to the shaft, which is usually of forged steel. Now, another component, draft tube. See here, it is pipe or passage of gradually increasing cross-section area toward its outlet end. It connects to the runner, exit to the tailpiece. So as the pressure of the reaction turbine decreases continuously as water passes through the guide vanes and the runner, it does below the atmospheric pressure at the outlet of the runner. Draft tube is used to discharge the water to the tail gas by increasing pressure above atmosphere. So draft tube must be submerged below the level of water in the tail gas. Means function of draft tube to increase pressure, simply increase pressure of the turbine. So today we have stopped here. Any doubt, any queries, please ask me. Any doubt, any queries, please ask me.